now what we're going to do is change it up and ask ourselves, well, what's going to happen if instead of going down initially, it's now being thrown upwards? As I said before, this projectile motion concept can be very tricky because there's a lot of things that you're going to have to balance. You're going to have to be able to remember what cases you have to do certain things in and what cases you would do the opposite in. So make sure that you pay attention. If you have any issues with this, please let me know as soon as possible. Come join extra help, or ask me to clarify some things. You basically want to make sure that you get a head start on this. Don't just wait until we go over in class. Now, the thing that we have to be careful with this whole throwing upwards is now we're going to be in a situation where the velocity and the acceleration are going in opposite directions. See, before, when we did the free fall problems, we had a case where the velocity was down, the acceleration was down, and we didn't have to worry about any signs. Now we're going to have to do that. I said before that anytime you have objects going in different directions, we have to denote that different direction by using positives and negatives. So that's what we're going to do here. So because our velocity is going upwards and our acceleration is going downwards, because that's the direction gravity goes, we know that it's going to be slowing down as it goes upwards, and we're going to have to denote that the acceleration is down by making it negative. Now, very common questions that you'll see with vertical projectile motions. One of them is basically how long is the ball in the air? This is usually called the time of flight. The maximum height reached by the ball, and sometimes a very uncommon type of question would be time to max height. What this means is that if you can recognize these three questions, if you practice doing these three questions, then you can do pretty much any vertical projectile motion question. Now, again, it may seem easy at first, but don't forget we have two other projectiles to deal with. So, again, there's going to be a whole lot that you have to kind of maintain and balance. And as I said here, depending on what they ask, it gives us a different piece of information. I said before that in this topic, in this unit of vertical projectiles and just projectiles in general, there's going to be a lot of hidden pieces of information, and this is what I was referring to. So here's a good example. Let's say a person throws a ball vertically upwards with an initial velocity of 20 meters per second, and you're being asked these three things: total time a ball is in the air, the maximum height, and the time to max height. Now we're going to want to take this bit by bit, and a lot of the information that we use in one of these parts may not carry over to the other part. So we're going to have to reset our entire writing down the known pieces of information. So remember, all the things that we want to do, these are the pieces of information that we have to keep an eye out for. So we have D, VI, VF, A, and T. So VI and VF and represent velocities. A is the acceleration. D, we're going to actually make the distinction, is representing our displacement. This becomes extremely important. D does not represent distance in these questions. It represents displacement. I recommend that every time you do a projectile motion question, you basically write down all of these. That way you kind of can look for each of these pieces and maybe even jog your memory. If you kind of do what we did before of reading the question and then pulling the information out from there, there's a good chance that you're going to miss out on the hidden pieces of information. So I recommend write this down on the side, then go through and see if you can recognize or identify any of these pieces, either from the blatant values that they give you or the hidden pieces. Now, starting off with part A, we're going to go through each part. Our displacement is going to be 0. The ball gets thrown upwards, and the total time the ball is in the air is for the ball to go up and then come straight back down. Now, normally, this question's not worded the best, but normally in a question like this, they would actually say the phrase, it lands at the same height it was caught at. So that's usually your tip, that the displacement's equal to 0. then our initial velocity is going to be 20 because it's thrown up. We don't know about the final velocity and we don't care. Remember, even though it gets caught or it stops falling in the air, we're not going to say the final velocity is zero because technically before it is caught, before it lands, it is still moving. So we don't know what the final velocity is. The acceleration is negative 9.8 meters per second squared because again, that's the acceleration due to gravity, and it's going down, which is why we make it negative. It's going opposite our initial velocity. And then time is what we're actually looking for. So when we look at all these, it's very clear that the equation that we're going to be using is the magic D. Now, normally when we've attempted to use the magic D equation, it wouldn't work too well with this because if you had an initial velocity and an acceleration, you had two terms with time in it, and you'd end up with a quadratic. But here, it doesn't happen. I'll show you really quickly how this would be solved, since some people end up having a little bit of issues. So we use d equals vit plus 1/2 at squared. Plugging in the numbers, we have 0 for d, vi is 20, t 1/2 of negative 10 t squared. Because of this 0, what this means is I can actually add the 5t squared, because that's 1/2 of negative 10, add 5t squared to both sides, and I end up with 5t squared equals 20t. I can divide a 5 from both sides, and I'm left with 4. And then I can divide a t from both sides, and I'm left with t equals 4. So that's how you end up solving these. Very nice. Basically, you are allowed to use the magic D as long as one of those terms becomes 0. Now for part B and part C, we can actually do them sort of together. So this time, the displacement is actually what we're looking for in part B, because that's going to be our maximum height. Now our initial velocity doesn't change. That's still from the very beginning, positive 20. But now, because they say the phrase max height, we know our velocity is 0. So this is important to remember. You throw the ball upwards. When it reaches the very top, that is the moment when it stops moving forward and upwards and starts moving downwards. So there's a moment where the velocity will be 0, and that's at the very top, the very max height. Because if there was any other velocity besides 0, then it would be going even higher. All right. Our acceleration, once again, is still negative 9.8. And then the time is something that we're going to look for in part C. So looking at this, it's very clear that in order to solve for part B, A, VI, VF, and D, we're going to use timeless in order to find this part, the VF squared equation. And then to find the time, we can pretty much use any equation, but we're probably going to want to use the acceleration equation. So I'm not going to go through the working that out because it's very straightforward from there. But yeah, that's what you're going to have to do. Now, one of the good things is for a majority of the time, if you forget to make your acceleration negative, it's very easy to fix and notice it, because a lot of times when you start doing square roots, you'll end up with a imaginary number or a negative time, and that usually tells you that you might have made a mistake. So you just double check and make sure you put the signs in the right spots. Alright, so here's the first practice problem. Read the question, work on this yourself, pull out the hidden pieces of information, and we'll go over it in a second. Alright, so we have a rock that's thrown straight up. They say at the highest point of the rock's path, they want the magnitude and direction of the acceleration. Well, at every moment when the ball is in the air, it is being pulled down, caused by gravity, with an acceleration of negative 9.8 meters per second squared. So the answer is 9.8 meters per second squared down. That is the direction. always and forever. Doesn't matter where it is in its path, it's always accelerating down at 9.8 meters per second squared. All right, here's the next one. Pause the video, work on itself. We'll go over in a second. All right, so what's the magnitude of the velocity? Again, we know this. At the very top, it stops moving. It's going to start coming downward. So the magnitude of the velocity is 0. Now, there is actually one thing that I want to mention, since a lot of people tend to think that just because the velocity is 0, that means it's motionless. Really quickly, just because its velocity is temporarily 0 does not mean that it's considered at rest. At rest means if you left it in that scenario, it would remain in that scenario. It would remain not moving. That's what at rest is. An object that's in the air is not at rest because it will eventually come back down. All right, here's the next question. Pause the video, work on itself. We'll go over in a second. All right, so we're going to write down all our variables, d, vi, vf, at, and then go through each one and try to pull out the information. So we have an initial velocity of 10 meters per second. So this is going to be 10 meters per second. We know that the acceleration is going to be negative 9.8 meters per second squared because the velocity is upwards and this is downwards. It says the phrase maximum height, so this is unknown. And then my velocity, final, will be 0. One good thing about this class is that one of these terms will always be 0, but only one term. So try to keep that in mind. If it's asking for total, it's the displacement that's 0. If it's saying max height, the final velocity is 0. So d or vf is going to be 0. And if it's a free fall, then vi is 0. From here, the only one we don't have is time, so that means we're going to be using the timeless equation. Vf squared equals vi squared plus 2ad. 0 squared equals 10 squared plus 2 times negative 10 times d. And we'll end up getting that the max height is, I believe, maybe 5 meters. Yeah, 5. And that's it. Here's the next question. Pause the video, work on itself. We'll go over in a second. Alright, so same initial information, but again, now that I'm asking for something different, it gives us different hidden pieces of information. So just like before, our initial velocity is still is 10 meters per second upwards. Our acceleration is now going to be negative 10 meters per second squared because it's downwards. It wants to know how long it's in the air. One of these two terms is going to be 0, and because it's caught at the same height, I know my displacement's the 0. From here, d, vi, at, that's the magic d again. Plug the numbers in, and we end up getting 0, 10 t plus 1/2 negative 10 t squared. So again, add 5 over here, we get 5t squared equals 10t. A t drops out, 5 cancels out, leaving this with 2, t equals 2. Easy peasy, 2 seconds. Alright, here's the next question. Pause the video, work itself. We'll go over in a second. Alright, so again, d, vi, vf, a, t. Ball is thrown straight up, so upwards with 8 meters per second. My acceleration is always negative 10. The maximum height, that's d. One of these terms is going to be 0, and it's going to be the VF, because at max height the final velocity is 0. I said before that these are all things that you're going to have to remember, but the more questions you practice, the more likely you are to see a pattern. For example, one of the most common patterns is that anytime they say max height, you're almost guaranteed to have to use the timeless equation. And any other scenario, you'll end up having to use um, the magic D equation. Again, that's going to be your main equation in this topic. And the distance should be 3.2. All right. Notice that they keep giving you these masses, but you have to remember that these are red herrings. They're extra pieces of information meant to throw you off. Remember, mass does not matter. Here's the next question. Pause the video, work on itself, and we'll go over in a second. Okay, so this one is a little bit trickier. Now, there's a few different ways to solve this. Now, one of the ways you could do this is use this information in order to figure out the initial velocity that the person jumped with, and use that to figure out the distance. You can do some other things that I'll actually end up using, but the main idea is that you have to split this question in half, because there's two things going on. We have a total time, which is referring to the person going up into the air and then coming back down. And then they're asking us about how high he jumps, which is just him going up to the maximum height. So these two pieces of information are not conclusive together. So what I'm actually going to do is this. In this class, we deal with what's called symmetric projectiles, meaning everything about it going upwards to its max height is equal to what's going downwards. So if it takes a total of 0.8 seconds for him to go up and down, that means the time it takes for him to go up is 0.4 seconds, and the time it takes for him to go down is 0.4 seconds. Now, again, there's a bunch of different ways that we can solve it. Some ways are quicker and easier than others. What I'm actually going to do is I'm going to do this slightly longer way, and I'm going to treat it like this. So the object is going up to its maximum height. Yeah, so we're going to do the whole D, VI, VF, AT. Alright, so D is what we're actually looking for. This is what we need to get at the very end, but we can't get there right now. VI, we actually don't know what VI is. We know what VF because it says the phrase max height. This is going to be 0. We know the acceleration is still -10 because it's still going down. And we know the time is 0.4. Now, as I said, there is no equation that has D, VF, AT. But what I can do is take a little detour and find the initial velocity first. So use the acceleration equation, VF equals VI plus AT. You can set this equal to 0. You can set the initial velocity as our unknown. Acceleration is -10, and the time is 0.4. So we get that the initial velocity is going to end up being equal to 4 meters per second. And now that we have this number, now we can figure out what the distance is by using VF squared equals VI squared plus 2AD. Remember, you are free to take detours, find all the other pieces of information if you don't know how to get there in one shot. Now, if you want, I can go over this in class if you're interested. But this is pretty much a good enough way of getting to the answer. Like I said, it's a little bit longer, but you'll definitely get there. So this should be, I believe, 0.8 meters. doing the math in my head. All right, and that's pretty much it. It's really important that you're keeping track of everything. Again, there's all these very niche things, and you want to make sure you have a very strong grasp of vertical projectiles before we start adding in the other ones. So don't just say I'm good at I feel comfortable enough. You want to make sure that you know this like the back of your hand before we continue, because if you don't have a firm grasp, as I throw more projectile questions to you, it's going to be very easy for you to slip and fall and drop all this stuff. So make sure you let me know if there's any issues. I'll try to explain it in a better way, come to extra help, see some extra problems. Otherwise, good luck and have a great day.